Good morning, everyone. My name is Chandrashekhar Sambhaji Patil, a doctoral student of J. University, who completed. I am completed my doctoral course in J. University under the guidance of Professor Jinobe, and today I am going to present my research achievements during my PhD journey and also one of my representative paper. Here in this slide we can I told about my table of contents, which we go with through this table of contents. First, we discuss about I told about self introduction. Secondly, we discuss research achievements, then work objective, and one of my representative paper. Lastly, a conclusion and future directions. Here, brief self introduction of my like education. I completed my Bachelor of Science and Master of Science from Shivaji University School of Nanoscience and Technology, Shivaji University, Kolhapur. And then after I moved Jejula University to complete my doctoral course under the guidance of Professor Jinobe. During my PhD journey, total I published 32 research articles and 14 are under preparation. Apart from the 10 research articles I published in first author, also I published four book chapters and one is under preparation. Total citation is 765 and IH index is 14 and I index is 19. My research expertise is mainly on nanostructured and functional materials synthesis and device fabrications and also integration. Uh, Integrating advanced devices with emerging technologies like EML, IoT, and the metaverse is also my main focus. Material characterization, in-depth analysis, and optimization. During my PhD, I awarded some awards like Big Brain Korea Award and Outstanding Research Award. Also, I also awarded by Students Incentive Scholarship, University Technology Malaysia, Kuala Lumpur. My PhD journey, my PhD thesis hierarchy objectives is like to develop sustainable energy devices and also to fabricate or synthesize the nanostructured advanced materials. The main or key goal to reduce the cost of the synthesis and the device fabrications, also to develop high performance devices and smart integration. As we know, the fourth industrial revolution, the 10 technology under drive and the fourth industrial revolution, like AI, machine learning, IoT, cloud computing, robotics, and autonomous and biotechnology. All these are fourth industrial revolution are connected together the active sensors. So my main research is to develop advanced nanostructured materials for the cell-powered and active intelligence sensing systems. As we know that the power and energy, the central challenge of our fourth industrial resolutions technologies, like all are connected to the power and energy, and which is the main or global challenge nowadays. As we know, the global energy crisis, everyone faces energy lack, so we need to develop some sustainable or renewable energy systems. Because traditional energy sources are depleting over the years, so the to climate crisis and resulting from the conversation and these traditional energy sources is both real and serious. Therefore, developing suitable energy technologies is a fundamental requirement nowadays because of its fossil dependence, climate change, price volatility, energy access inequality, and grid instability. At the moment, there are three sustainable energy technologies like triboelectric, piezoelectric, and electromagnetic nanogenerators. During my PhD, I mainly focus on triboelectric nanogenerator and piezoelectric nanogenerator because of its cost and high performance. As we know that Teng and Peng, the Teng is triboelectric, basically depends on triboelectric effect and electrostatic induction. like triboelectric effect, when two materials come into the physical contact, then separate. One material tends to gain electrons while other electrons leading the generate opposite surface charge. And electrostatic induction, the separation between triboelectric charge creates potential difference. There are four types of working modes in triboelectric energy generator. First is contact separation mode. Second is lateral sliding mode, and freestanding layer mode, and single electrode mode. However, in piezoelectric energy generator, the energy we generate due to the piezoelectric effect, and here is the principal mechanism of piezoelectric energy generator. The current requirement in triboelectric and piezoelectric energy generator is high voltage, fast response, self-sustainability, scalable fabrication, intelligent interference, and environmental robustness. These are the main key current requirements which I focused in my PhD course. To meet these current requirements, one solution is the advanced non-structured materials. Development of advanced non-structured materials is the key solution. Therefore, I mainly focus to develop advanced non-structured materials. Through this advancement, we can develop novel materials. Also, we can tune the dielectric nanomaterials, hydrophobic materials, variable resistant nanocomposites, moisture resistance, and encapsulations. So, during my PhD, I published several articles. Apart my work, here is the key work, like entitled Synergetic Integration of Graphene Quantum Dots into the Metal Organic Framework for Enhancing Triboelectric Energy Generator Performance. In this work, the key advancement is the advanced non-structural composite material for high voltage staying. Also, the developed material is highly environmentally independent and it's also applicable for active sensor system. Here is the experimental and characterization. Like in first figure, we can see the exact experimental procedure, and here in figure B and C, we can see the zeta potential analysis. Further in figure C, we can see the FESM analysis and elemental analysis. Further, here we can see in this slide the XRD, FTIR, UV analysis, and Raman and beat analysis. Here the actual advancement, like the bare MOF was show only limited performance. Then after composite, we combine with the graphene quantum dots and enhance its electronic properties, and we can see it's show that remarkable output performance as compared to the pristine MOF. There are some electrical measurements, like figure A, we show the power measurement of the pristine MOF and graphene quantum dot MOFs, and figure D show its environmental robustness. We can perform its performance in several environmental conditions, like humidity and temperature. And lastly, in figure E, we can see the stability performance, like our device show near about uh, 30,000 cycles. It show the same performance. For real-time applicability, we can check its applicability for calculator operating and LED glowing, and also for human motion monitoring, like tapping, jumping, and running. And according to our human motion, it can show its sensitivity, and we can monitor the human motions through machine learning IoT systems. Also, in this work, we check its ability to measure or to monitor the vehicle speed monitor. Here, using the generated signals, we can calculate the speed of the vehicle through machine learning and IoT, and we can predict what speed or speed of the vehicle. And this work was published in Advanced Composite Material, having impact factor 23.2. Conclusion, the overall conclusion of this work, like we need to like generate sustainable energy materials, focus on the like for high performance tank devices, also self-powered energy harvesting technology, explore tank and ping for energy generation, adaptive sensing technology to develop intelligent sensors for various applications. Also, self-powered energy storage technologies enhances energy storage through advanced materials, and also creates interface between the sensors, AI, machine learning, and IoT. My future research directions to my prioritized research direction is to develop scalable device fabrication technologies. Second was to hybrid energy harvesting systems. Third one, stretchable devices. Also interface with AI, machine learning, and IoT, incorporating machine learning for intelligent sensor systems. Further exploring biodegradable materials for ecological sustainability. Also cross-disciplinary collaborations with diverse specific fields. Thank you.